So we have y prime plus y tan x that's equal to sec x. So this is a first order differential equation. So when you have a first order differential equation, first thing you need to do, step one, find your integrating factor. Your integrating factor I like to call it I, integrating factor is e to the integral of tan x. Now when you integrate tan x, you get ln sec. So the answer works out to be e to the ln sec x. But e to the ln, e cancel ln, and so you just get sec x. Now when you get sec x, you don't done yet. So what you have to remember is that when you get sec x, you're not finished. You have to remember now, the second step is you're going to write that the general solution is y times the integrating factor I is equal to the integral of sec x times the integrating factor. So it's equal to sec x times your integrating factor of sec x. And you're integrating with respect to x. All right, nice and easy. So what we're getting is y times sec x is really y over cos x, because sec is 1 over cos. So y over cos x is equal to the integral of sec times sec is sec squared. So we get sec squared x. Now when you differentiate tan x, you get sec squared. And so when you integrate sec squared x, you get tan x. So you get tan x plus some constant c. All right, and so this is y over cos x. Now you want to make y the subject, so you're going to multiply through by cos x. Multiply through by cos x, you're going to get y is equal to tan x times cos x. Y is equal to tan x times the cosine of x plus your constant c times cos x. All right, nice. Now we're almost finished. Almost, but not quite. Now one thing we need to realize is that, remember, what is tan x? Tan x is equal to sine x over cos x. All right, that is tan x. Tan x is sine x over cos x. So if we cross multiply up here, we see that tan x times cos x is sine x. So tan x times sine x is equal to tan x times cos x, sorry. Tan x times cos x is sine x. Tan x times cos x is sine x, just by cross multiplying. So since that is what we get, then we can resubstitute right here now. We can resubstitute for tan x cos x as sine x. And so what we're getting is y is equal to tan x cos x, which is sine x. So y is equal to sine x plus c cos x. Nice and easy, soft. So right, shown. What's the next part? It says, hence obtain a particular solution where y is 2 root 2, 2 over root 2, and x is pi by 4. So it wants us to obtain a particular solution. So we just found that y is equal to sine x plus c cos x. Now all you're going to do is find what is c. So when x is pi by 4, y is 2 over root 2. So 2 over root 2 is equal to the sine of pi by 4. I don't like to write so much pi, so I'm going to write 45 degrees. The sine of 45 degrees plus c times the cos of 45 degrees. Now, the sine of 45 degrees is sine 45. I think that's root 2 over 2. This is going to be root 2 over 2 plus cos of 45 is the same thing. It's root 2 over 2. So it's root 2 over 2 times c. And then over here we have 2 over root 2. So now we need the denominators to be the same. So I'm going to multiply this by root 2. So I'm going to write this as 2 root 2 over 2. So this is the same as 2 root 2 over 2. Now when the denominators are the same, I can equate the numerators. And so I have 2 root 2 is equal to root 2 plus c root 2. And so if root 2 is equal to plus c root 2, then c must equal 1. Therefore, c must be equal to 1. If c is equal to 1, then the specific solution then is y is equal to sine x plus c cos x. C is 1. Nice. Let's look at part B now. So right here we had, all right, so now finally we're at the last part of the question. We're looking at part B, and part B says a differential equation is given by y double prime minus 5y prime, and that is equal to x e to the 5x. And in order to solve this differential equation, step one is to solve the auxiliary equation. So step one, solve the auxiliary equation. Find the roots of the auxiliary equation. So the auxiliary equation will be, I like to call it u squared minus 5u, and that is equal to 0. So if we're solving this, what we're going to get is, this is then going to tell us then that u is equal to 0 or u is equal to 5. Once you get the roots of the auxiliary equation, step 2, that allows you to find the complementary function. So the complementary function, generally you see people call it yc. The complementary function is equal to, let's call it, it's equal to pe to the u1 to the u1x, so it's going to be pe to the 0x plus qe to the 5x. All right, so in reality, this part is going to simplify up to be that the complementary function is given by p times e to the 0x is just p, so that's just p plus qe to the 5x. Now, The second part now is to find step 3. We need to find the particular integral. So to find the particular integral, let's do that on a fresh page. We need to find the particular integral, EI. Generally, people call it YP. All right. In this case, to tell us what the particular integral YP is. So since they gave us YP, we can find, so let's write it around here. They said that YP is equal to AX squared e to the 5x plus bx e to the 5x. All right, cool. So once you have the particular integral yp, what we need to do is find the first derivative now, which is yp prime, and that's going to be equal to, we have to use product rule. Using product rule, we keep the first, which is ax squared, times the derivative of the second. The derivative of e to the 5x is 5e to the 5x, plus, you're going to keep the second now, keep the second, which is e to the 5x, times the derivative of the first. The derivative of ax squared is 2ax, plus, we're going to go ahead now and differentiate this. Differentiating bx e to the 5x, we keep the first, which is bx, times the derivative of the second, which looks like 5e to the 5x, plus keep the second, which is e to the 5x, times the derivative of the first. When you differentiate b times x, you just get b. So all I'm going to do is write out this a little bit better. So yp prime is going to be 5 times a is 5ax squared e to the 5x plus, this can now be written as 2ax e to the 5x plus, this can be written as 5bx times e to the 5x plus be to the 5x. Nice and easy. So that's what we have. Now we need to find the second derivative. To find the second derivative, it's going to be yp prime prime. And when we find that, that's going to be equal to, differentiate this using product rule again. So we keep the first, which is 5ax squared, times the derivative of the second. Derivative of the second is 5e to the 5x, plus we keep the second, which is e to the 5x, times the derivative of the first, and the derivative of the first is going to be, differentiate 5ax squared, that's going to be 10ax, plus we're going to differentiate 2ax e to the 5x. We're going to keep the first, which is 2ax, times the derivative of the second, which is e to the 5x times 5. So I'm just going to put 10. Plus keep the second times the derivative of the first. Derivative of the first is going to be 2a e to the 5x plus, now to differentiate 5bx e to the 5x, that's going to be keep the first times the derivative of the second. 5 times 5 will give us 25 bx e to the 5x plus keep the second, which is e to the 5x times the derivative of the first, which is 5b. So this is really working out to be plus 5b e to the 5x plus the derivative of b e to the 5x is just 5be to the 5x. So if I were to simplify it now, I would realize that yp prime prime is actually equal to, I'm just simplifying now, 5 5 is 25, that's now 25ax squared e to the 5x, then this is going to be plus 10ax plus a 10ax, I'm going to write that as plus 20ax e to the 5x. Then I have plus 2a e to the 5x plus 2a e to the 5x plus 25 bx e to the 5x. Good. Plus 5b e to the 5x plus 5b e to the 5x is 10b e to the 5x. So that gives us the second derivative. Nice and easy. Now what are we going to do next? After we get this now, well, let's look back at the question. Y double prime minus 5y equal x e to the 5x. So first we need to find out what is, I'm going to do it in another column. We need to find out what is yp prime prime minus 5yp prime. If we work out what that is, that will give us, so pretty much if we were to, I'm going to do it in green, if I were to multiply this by 5, if I were to multiply this by 5, then this would become 25, and this would become 10, and this would become 5 times 5 is 25, and this would become 5. All I did was multiply through by 5. Good. Now I'm able to subtract them. 25 minus 25, that becomes 0. 20ax minus 10ax, that just works out to be 10ax. So I get 10ax e to the 5x. All right, cool. 25bx e to the 5x minus 25bx e to the 5x, that cancel each other. All right, and so what I'm left with is 10ax. All right, what else? Now this right here, which is 10b e to the 5x minus 5b e to the 5x will leave me back with 5b e to the 5x. I will leave me back with 5b e to the 5x. And I think I have, what else is left back? And I have plus 2a e to the 5x. And of course, the question had said that all of this is equal to x e to the 5x. So we can write that around here, that this is equal to x e to the 5x. Nice. X e to the 5x. So now we can use that and set up our two equations to solve for a and b. I want you to observe that. Look at this. What are we saying? We're saying that if you underline this, you have 10ax e to the 5x is xe to the 5x, and then you have 5b e to the 5x plus 2a e to the 5x. That part must equal to 0. All right? So we can continue around here now and write those two equations down. But it must be that the 10ax e to the 5x, 10ax e to the 5x, that must be equal to x e to the 5x. And so if we divide through by e to the 5x, we're getting that 10a is equal to, divide through by x e to the 5x, we get 10a is 1, and so a is 1 over 10. All right, now that we get a is 1 over 10, what else we need to find? We need to find b. Now 5e to the 5x plus 2a e to the 5x must equal 0. That's the second equation. That 5a e to the 5x plus 2a e to the 5x, 2a or 2b, 5b e to the 5x plus 2a e to the 5x. This is supposed to be b. Change that to b. And you might wonder where the 0 comes from. The 0 actually comes from, it's actually saying that this is equal to 0 e to the 5x. That's where the 0 comes from. You might say, how did I come about the 0? Remember, all of this is equal to x e to the 5x. X, you group in like terms. If 10ax e to the 5x, these two terms have the x times e to the 5x. These two terms don't have the x times e to the 5x, and so it must equal to 0 times e to the 5x. So that's how this equation come about. We can then divide through by e to the 5x to get 5b plus 2a is equal to 0. And if 5b plus 2a is equal to 0, then we can make b the subject by getting that 5b is equal to minus 2a minus 2 times a, and a is 1 over 10. And then we can divide through by 5, and so b is going to be equal to, this looks like minus 2 cancels to become 1, canceling that to become 5. Doing division, this works out to be 1 over 5 times 5 is 25. So a is 1 over 10 and b is minus 1 over 25. So that means we know our particular integral then. Our particular integral is going to be ax squared, and a is 1 over 10. So now our particular integral is 1 over 10 x squared, 1 over 10 x squared e to the 5x plus b, and b is minus 1 over 25 minus 1 over 25 x e to the 5x. Now again, this is not the answer. We don't finish yet. So now we need the general solution. You have to remember that the general solution is equal to the complementary function plus the particular integral. That's the general solution. And so finally we can write that y is equal to the general solution, which is p plus q times e to the 5x, p plus q times e to the 5x plus yp, and yp is 1 over 10 x squared, 1 over 10 x squared times e to the 5x minus 1 over 25 x e to the 5x. Nice and easy, soft. This is the solution. All right. And so we have come to the end of this paper for 2014. Do see you soon, and just make sure to subscribe to the channel, and all the best prepping for your exam.